pressure looks good.
Doubling up. Roger roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Body bounce speed off. Bring in, speed off. Off.
Yikes. You bet. Concur. We don't need any more of these.
All right, folks, you know the drill. Give me a 5x5 in chat over there because it is time for another launch, a rare launch today. A unicorn. If it's not even a unicorn, there's more than one of those out on the pad for United Launch Alliance. We've got an Atlas V in a never-before-flown configuration. Tori Bruno referred to it as the big slider, the Atlas 551. We'll talk a little bit more about what that means in just a minute, but this is going to be a cool one. It's a very efficient launch today. They are launching 2 satellites for the U.S. Space Force using only 1 SRB. So we've got the team out in the field today. Let me make sure we've got those 5x5s in chat. Yes, thank you so much. Part of our remote production crew letting know that you can hear us and see us. And Michael, is this a 551 or a 511, actually? Interesting. All right.
It's a 511.
It's a 511. Yes. On the overlay there, that will be resolved shortly, and you can tell where I'm reading my information from. It is actually a 511, like it says on the overlay now, because there's one SRB. So that would be a very interesting configuration, the 551. So let's see here. Like we said, we got the NASA Spaceflight team out in the field, starting with Mr. Chris Gebhardt, Assistant Managing Editor for NASA Spaceflight. Chris, how you doing today?
I am doing just well out here in my native habitat, so I'm doing well.
All right. And Chris, we've got a couple other people in the field. I'm going to bring their microphones up in just a second. But if you could, tell us a little bit about this mission now that we've got the right numbers on the overlay.
Yeah, indeed. So it's a fairly exciting mission, Das, like you pointed out. So it's somewhat oddly there's like a pseudo classification to it. We know the satellites that are on board. They are 2 GSSAP satellites, and that stands for Geosynchronous Space Situational Awareness Program. And these are basically 2 satellites that will be able to go up and inspect other satellites operating in geosynchronous orbit. So this is a very interesting mission for the U.S. Space Force. Continuing on from a program which gave them the capability in recent years to study foreign satellites and monitor their operations in orbit. So these 2 GSSAP satellites, which are the 5th and 6th in the overall series, are what is on top of the Atlas V rocket today. And as you alluded to, this is a never-before-flown variant of the Atlas V. It is flying in its 511 configuration with a 5-meter diameter payload fairing, a single solid rocket motor, and a single engine Centaur upper stage. So quite a bit of asymmetrical thrust on this one at liftoff, which is why it is called Big Slider, because it will power slide off the launch pad with that asymmetric thrust. So a very good mission, a very exciting mission, and United Launch Alliance's first of 2022.
Good deal. So again, y'all, this is going to be an interesting launch today because of the fact that this thing is going to slide. I'm sure we'll get lots of questions about how the rocket can actually launch with asymmetrical thrust in 1 SRB. We'll get into that in just a minute. Let me introduce the rest of the NASA Spaceflight team that is out in the field today. I know out there with Chris, we've also got Mr. Thomas Burghardt. Thomas, how you doing today?
I'm doing great, Das. Good to be back out here at Cape Canaveral Space Force Station for another launch, and any launch day is a good day.
All right. Of course, Thomas Burghardt, you hear his voice on the streams all the time. He's the news director for NASA Spaceflight. Also in the field today, we've got Miss Julia Bergeron. Julia, how you doing?
Why, hello there, everybody. I am doing fabulous and looking forward to this unique rocket doing its job.
Excellent. So Julia will be joining us as well for some commentary. Our resident fleet chaser and photographer. Speaking of which, look at this. We've got a ship coming in over here on Fleet Cam. That looks like it's Doug returning with... Did it catch something? It looks like it caught something there underneath the storage area.
Hey,
That's
look at
Terry.
that. There's at least one fairing there.
Yeah, there's
2.
2. What is it? 1 fairing or 2 fairing halves? Like
Okay,
by
fine.
their powers combined, they make a fairing, right?
Right, exactly. It's 2 fairing halves, and I believe this would be the second time for both of them for being recovered.
Where are these coming in from? What mission did these fly on?
These just flew on. Oh my goodness, I think we just had another Starlink mission. Yes, it was group 4, 5?
4-6? 4-6.
4-6.
Pretty sure it's 4-6. There again, Starlink, whatever the last one was.
Whatever the last one was. It looks like they need to mitigate some of that rust on the side there. They got a couple little rusty bits. Of course, Doug is one of the 2 new custom-built ships for SpaceX they're using to support their recovery operations. You can see that big crane on the back capable of picking up those fairings with ease. We've also seen them doing some towing out there. Not big enough to actually land a rocket on. That's not what they're intended for, but that's really cool.
Not with that attitude, Doss.
No, not with that attitude. Hey, with Elon's attitude, he's probably going to install another crane and make some chopsticks on that thing and try to catch a rocket with their ships. Anyways, that's coming in from Fleet Cam. That was actually really good timing there at the beginning of the day. Also, really quick, out in the field, we've got Stephen Marr. I don't believe he's going to be on comms, and we'll be bringing up his camera. He's actually at a different location. So if y'all want to start running with some more things about the mission, I can see if we can't get Steve online.
Well, I have a question for you, Thomas.
Oh boy.
We've had so many launches where it's like single-second instantaneous. What do we have here today?
Today we have the classic case of guess the launch window, because our somewhat classified, not really classified, but semi-classified mission for the U.S. Space Force, it does have a launch window, and it opens at exactly 2 o'clock p.m. Eastern Time. And the first hint that you don't really know the exact launch window is when it opens at the top of an hour, because sure, that can happen sometimes, but usually it doesn't. Usually it's some very specific number. So the fact that it's at a nice round number indicates that you do have kind of a generic launch window to work with. ULA or the Space Force, neither of them have specified how long today's window is, but it is not instantaneous. So there's some unspecified window. The hazard zones seem to indicate it's a few hours, maybe 3 to 5 hours, somewhere in there. But those hazard zones also aren't the exact launch window. So we do not know the exact length. However, luckily, so far, no issues are being tracked. The board is green per the latest reports from ULA. So hopefully we just go at the opening in the window and it doesn't really matter. But should anything come up, whether that's weather-related or a technical item, they do have some time to work with it and go through those built-in holds that ULA has in their countdown, or some unplanned holds if they need to. And they have time to work those out before launch should they need to. Today's mission is going all the way to geostationary orbit, or it's a very near geosynchronous orbit, I should say. But all the way there, a direct insertion, the center arbor stage will actually conduct a burn to circularize at near geosynchronous altitude before deploying the 2 GSAP satellites that Chris G talked about earlier. So it's a nice long mission profile, but missions to geostationary, especially all the way to geosynchronous, the power requirements are a little bit different because usually the upper stage is actually supplying power to those satellites. Now, I know ULA demonstrated that on a previous mission. I don't know if they've mentioned whether they're doing that again, but basically when you're going all the way to geosynchronous altitude, you have slightly different requirements than other missions that have transfer orbits, and the satellite needs to be power positive as soon as it deploys. There's those kind of factors in consideration. So all of that is a pretty long way of saying we have a launch window for today's mission to geostationary orbit.
Excellent. And like I was mentioning, we also had Steve out in the field. There we go. A little bit of a different angle today. Steve is actually a couple miles down on Cocoa Beach, and we'll see if this rocket, launched by United Launch Alliance, gets the attention of these beachgoers in a little bit. Coming up on 30 minutes, we're just over 30 minutes before the opening, the L- there, the opening of the window for the launch. Let's see here. As always, y'all, you know we do these shows live. That's why we have the live people talking, both out in the field and back here in the studio. So we're taking questions. If you have questions for us, tag us in chat. Just put @NASASpaceflight. We've got some cool software that Michael's written, and we'll see if we can't answer some of y'all's questions. Also, see some super chats coming in. We're able to do all the cool things we do because y'all keep showing up, and we appreciate the financial support there. Rough Riders Show, thank you so much. A little bit of a question we can toss out to Thomas and Chris here. What's the fastest turnaround time for SLC-41 between missions? Anybody? I don't know.
Oh gosh.
They can do it in about a month if they bare bones needed to. However, they have not had to demonstrate that in a particularly long time. But they can do it in about a month if they need to.
Gotcha. So
There
there
are a
you
couple
go.
factors that influence that. I'll add on just really quick. If there's a
Yeah.
mission with a bunch of solids launching first, sometimes the refurb and cleanup after one of those missions is more extensive than if you had like a 401 or a 501 with no solids on board. Also, another factor is if they have to reconfigure umbilicals. So if you're changing the fairing type or any other reason you need to adjust the umbilicals on the mobile tower, that can lengthen the turnaround time. I'm sure there are other factors as well, but those are things to consider in that discussion.
And you know what? Thomas, we're going to have to consider a few more other things when Vulcan starts launching, because that pad is one of the unique pads that can actually launch 2 different families of launch vehicles. So that will also alter the turnaround time at the pad, because you can switch from an Atlas to a Vulcan and back again.
It's true, which means that you might have different or longer refurb times on the pad systems that are used for both families. However, and we can actually catch a peek of this from our point of view. It's kind of just out of the point of view where the camera might see it, but the mobile launch platform for Vulcan is actually sitting in a building kind of off to the right of the pad. And because they use different launch platforms, interchanging them might even be faster, because you can be refurbing the one launch platform while the other one rolls out, launches a different mission. So it'll be interesting to see, once they're both flying at the same time, how that overlap works out.
See, look at that. One little question, we can talk about it for 5 minutes. Hey, Westy the Third, thank you for the support as well. Says, evening from the UK. How is the launch configuration for Atlas decided? That's a good question, because we know there's a lot of different configurations. Pick me. Thomas, since you raised your hand, go ahead.
So there are a couple of different factors, and we'll talk about this mission specifically. So this flight is, like I said, going pretty much directly into a near geosynchronous orbit. So if I keep saying geostationary orbit, I mean a near geosynchronous orbit, but basically a very high orbit, and it is circularizing with Centaur once it gets out there. So you need a lot of energy left in that upper stage to conduct those maneuvers. The spacecraft themselves are relatively small. However, there are 2 of them, and they need to be sitting on an adapter. So I believe that drove the bigger payload fairing, the 5-meter payload fairing. 2 spacecraft on an adapter, even though they're both individually quite small. So that decides the payload fairing volume, mostly the size of the spacecraft or whatever deployer they have to be on. Also, and we say 4 meters and 5 meter pairing. There's also different lengths. I don't know the exact number on length off the top of my head for this one, but the fairing can also be different heights vertically. But anyway, so the payload fairing size was determined by the spacecraft, and then you do the rest of the math to figure out what orbit you're going into and how much energy you need to do that. Basically, if you have no solids on board, that is the minimum energy version of Atlas. And the more solids you strap to the side, the quicker your first stage can throttle down during the initial part of the descent, because the solids are providing a bunch of extra thrust. And that means you have more fuel left over in that center stage once the solids separate, and the first stage will then burn longer. And that all happens before you then going into the fuel that's on board your Centaur upper stage, which pretty much never changes. And so the energy required to insert these 2 satellites, that however much they weigh, directly into a near geosynchronous orbit, required just a little bit more than no solids on the rocket, but you don't need 2 solids. If you strap just one, it'll work just fine. And we can talk about asymmetrical thrust in a second, but the amount of energy added by a single solid rocket booster is just enough to give the Space Force and ULA the margins they needed to deploy these satellites into the orbit they desire. So it's all about how big the spacecraft are and where they are going.
Good deal. That's there's the explanation. Let me hit that really quickly. We talked about, this is an Atlas V, right? It's United Launch Alliance. It's an Atlas V, and they write that as Atlas V, Roman numeral mode. But then it's got that number after it, the 511. And in terms of the 511, that actually describes the build of the rocket. That first number, the 5, describes the diameter of the payload fairing up at the top. You can have a 5 or a 4 there, and this is the larger 5-meter fairing, like Thomas said, to fit those 2 satellites on the payload adapters. The second number is the number of SRBs. Thomas said that this is one SRB. It needed more than 0, but it needed less than 2. So that 5-1, the second number, says that they've got one SRB on board, which is why we have asymmetric thrust. Literally, if you're a Kerbal fan, you just strap one SRB to the side, you hit the space bar. What the heck does that do? We'll talk a little bit more about that in just a second. The last number there is the number of engines in the upper stage, and most of them fly with a 1. I think some of the Starliner missions and maybe one other thing have a 2 back there.
I think on Atlas V it is actually only the Starliner missions, and that's for the very unique trajectory that Starliner missions fly for in the event of an in-flight abort to minimize the G-loading the astronauts would experience. The trajectory is a little weird, and they want a little extra thrust on the upper stage. Also, if one of the engine fails, you have redundancy on a 2-engine stage. But for all of the uncrewed missions and satellite missions, Atlas V only has 1.
There you go. So that's sort of the why they configured it this way and how we know it's configured this way. I mean, A, they told us, but B, it's right there in the name, 511. 5-meter fairing, 1 SRB, and 1 Centaur. Now that I'm saying it correctly and not saying 551. Chat, class, here's a question. If it was a 551, how many SRBs would it have? Go, put it in chat. We'll grab some more questions here. Remy Turk, thank you so much for the support. Another quick question. Have there been such asymmetric non-Atlas launches before? Oh, were there any, Chris, pay attention, were there any launches, hint, hint, that were asymmetric thrust that were not Atlases?
Oh my, yes. Yes, this should not be a surprise at all. Yes, the space shuttle was a huge asymmetric thrust vehicle. The 3 liquid-fueled main engines would fire through the center of mass, but were offset. So the shuttle would actually slide back and push off the pad itself before it rolled and got onto the proper course. So yes.
There you go. Just by verbally tagging Chris, I probably gave the answer away, right?
A little bit.
Great question there, Remy Turk, and thank you for the Euros. Dennis Clips, appreciate you as well, stopping through. We've got a sedated, all right, says shout out to symmetrical or asymmetrical thrust. Keep up the great work, guys. Thank you so much there, sedated. We appreciate the support. Woolly Samoth, nice. Says, no question, just want to give you guys some props. Love you guys. We appreciate the kind words there, Woolly Samoth. Thank you so much. And then finally, Mike Battaglia? Let's go with that. What do we know about the payload? Are these 2 satellites intended to work together, or will they be diverging after release? And what actually are they doing? Like, what is the mission of these satellites specifically?
Yeah, so ideally they work together. They work in the little pairs that they go up with. But basically what this allows, basically what the 2 satellites allow on this is the ability to monitor how other satellites are operating in geosynchronous space, to monitor what they are doing, not just how they are functioning. And obviously there are domestic applications to that where the military could go up and look at its own satellites and inspect them. But this can also be used for foreign satellites to go up and to also look at them. And this is a fairly common thing that is done in terms of like watching what your potential adversaries are doing. It is worth noting that since these and other ones on the US side do get close to other satellites, that Russia has very recently done very similar things that we have seen, where they have launched satellites that have gone up and sort of station kept and followed and shadowed our spy satellites. So we do the same to them, they do the same to us. Everyone sort of does it. So this isn't a new capability. It's just a continuation of a capability we've had for some time while testing some newer things. And Thomas, do you want to take what some of those newer things are?
So I admit my knowledge on this program is pretty limited. So I think I would if you know more, then you should just feel free to keep talking.
That works. So in essence, they are a continuation of a program. So building on earlier experiments such as MITEX, which was the microsatellite technology experiment with satellites performing an array of experiments, including these things during the early 2000s. They're also looking at, so this particular mission is also working alongside some other demonstration missions such as Angels as well. So an ongoing effort here.
Excellent.
And for those who are wondering, the specific two satellites on here, the GSS-8P5 and 6, were both built by Northrop Grumman using the GeoStar 1 satellite bus. So they are lightweight satellites, but we don't know their exact mass.
Gotcha. I'm going to grab a couple more questions here. We've got a couple, like one quick good one. Let's see. How tall is Vulcan compared to Atlas V? Like this Atlas V is almost seems to be peaking up above the top of the service tower there. But is Vulcan going to be bigger than this, smaller than this?
Yeah, so I mean, one of the interesting things about the Atlas that you see here with this big payload fairing is the 5 variant with the 5-meter payload fairing does stick out above the top of its structure there, but the 4 variant does not. So to answer the actual question, the Vulcan stands 61.6 meters tall. So in relation to the Atlas V itself is a rocket that stands 58.3 meters tall in its 5-meter payload fairing configuration. So Vulcan is slightly taller, but you're not really going to notice it.
Gotcha.
That makes sense.
Yeah, I mean, it looks sort of weird with that fairing on top, that 5-meter fairing sort of bulging out the top. I know it's a little bit tough to see with the contrast, the sort of the overcast that's going on or whatever. But anyways, folks, if you're just joining us, we're coming up on T-minus, or I guess it's L-minus because it's ULA, L-minus 20 minutes here before the, let's say, opening of the window. There is a window. We don't know exactly what the window is, but it does seem that they are targeting the beginning of the window here, which is just under 20 minutes away now for the launch of USSF-8. Say that 8 times fast. A launch by United Launch Alliance for the United States Space Force with some, let's say, inspection satellites on board. So
that's
Tom,
a good way to put it.
Inspection satellites, right? It's very a politically correct way to say what those things are supposed to do. So Thomas, earlier we talked about the fact that this is a big slider, Tori called it, the Atlas 551 with an SRB strapped to one side. Like I said, I've tried that in Kerbal and it never turns out well. Why can ULA pull it off and I can't? Well, all right, whatever. I can pull it off in Kerbal. Anyways,
Right,
tell
yeah,
us
you
about
guys you just got to pick the right first stage engines, which is the same thing that ULA did in real life. The main thing that enables Atlas V to fly asymmetrically is how much the RD-180 main engine that's on that first stage can gimbal. And in other words, also known as thrust vectoring, basically you can swivel the nozzle of the engine and point the thrust in different directions. Almost all liquid rocket engines can do this. It's how most rockets steer. But the RD-180 can actually gimbal so much that it can offset the asymmetrical thrust from just a single solid sitting on the side and basically cancel out the horizontal thrust, and thus the rocket flies straight vertically. So that's a capability given by that center RD-180 engine, and is actually present across most of the Atlas V variants. Obviously, the one booster variant is one where it's most obvious. However, even the 551 configuration, where there are 5 SRBs, there are 3 on one side and 2 on the other. They're not evenly spaced. So the thrust is actually still a little bit asymmetric. It's way less noticeable, and the engine has to gimbal less to offset it, but it is still technically asymmetrical thrust. And that is a capability that Atlas V has always had. If you look ahead to how ULA will be incorporating the Vulcan rocket in the future, the BE-4 engines, there will be 2 of them on Vulcan. I do not believe offer that capability, and ULA, at the very least, ULA has said there is no plans to fly asymmetrical thrust configurations on the Vulcan launch vehicle. Instead, you'll have options of 0 solids, 2, 4, or 6. So only even numbers where you can put 1 on each side or 2 on each side, etc. And the kind of trade-off for that is, on this mission, like we talked about, the energy only requires 1 solid booster. But if you didn't have the asymmetrical thrust capability from the main engine, you would need to put 2 on, because obviously if you do 0, well, you're not going to make it. And if you put 2, you can still reach the destination orbit. You'll just have extra energy left over in that upper stage. However, you save cost, you save launch processing time, and things like that. You might even reduce like launch vibrations, since there's only 1 solid. You can get some benefits if you only need to put on 1 and can use asymmetrical thrust. So that's a trade-off there. Vulcan will not have that capability. So Vulcan, if you only need 1 SRB of energy, you got to buy 2 for Vulcan. And that goes for the majority of rockets that use strap-on solid boosters. If you look at the H2 rocket in Japan, there's only the 2 and 4 configuration. Trying to think what other rockets even use. The Ariane 6 will have a similar scenario. Yeah, so that is more or less more normal. Atlas V is pretty special in that case.
Yeah. The only other rockets I can think of that use single solid rocket motors are the rockets where that is the entirety of the first stage themselves, like the Minotaurs and the Vegas. But other than that, I think Atlas is the only one that can do it with that level of asymmetric.
Maybe even like previously proposed crew launch vehicles that were shuttle derived, and I might be a slight fan of cough cough Ares 1 fan club.
Well, we'll let you hold that thought.
You hold that thought. Nice. Oh, geez. Let's. I'm gonna keep getting some questions here.
Yeah, please do.
We still have time before the launch. About 15 minutes coming up. Let's see. Oh. Insert standard question. Somebody answer the standard question for us, please. Just get it out of the way.
So the 4 towers that are around the rocket are the lightning protection system. And here at pad 41, there are 4 of them, just very similar to pad 40 right next door. Some of the other pads have different numbers, but that protects the rocket while it's sitting on the pad from lightning strikes, which are pretty common here in Florida. Won't be too much of a problem today. Pretty thin clouds out here today, although it is still overcast. But that's the lightning protection system. So the 4 towers are lightning rods.
We're going to have to mix that up, y'all. Every single stream is sort of running a gag here. Viewers will ask, what are the 4 towers for? And so when I say insert the standard joke, we're talking about what the 4 towers are for. One of these days, we're going to have to do like what are the 4 towers for? Wrong answers only. It's like, that's where United Launch Alliance stores the standard bananas. It's a standard banana silo. But anyways,
what we can point out, because we briefly talked about it earlier, I think you called it a service tower. There is a 5th tower that's kind of in your view, just to the left. Well, actually, there's 2 of them. To the left, 2 towers left of the rocket, but not the lightning protection towers, is a new tower to pad 41, relatively. That is a crew access tower. They built that for the Starliner missions. It has a crew access arm on it. And then between that and the rocket is actually the, I believe it's called I think it's called an umbilical tower is the technical term. That's actually on the platform that rolls out with the rocket, and that carries fuel lines, data lines, electrical lines, things like that, all of the umbilicals that connect to the rocket.
Right.
So there are other towers in view.
Yeah, that's the one that says ULA on it, and white letters, the gray tower
Yes.
with white ULA, that actually rolls out with the rocket. It's part of the moving structure. They build it in a building, right? And then they roll it out to the pad, and that ULA structure that says ULA in white letters on it helps support the rocket while they're moving it and carries the fuel and umbilicals up the side of the rocket. Exactly. And I guess that's is it the service tower, the crew access? Is it an official name?
I think they call it the crew access tower, I think is the technical term.
Yeah.
And
like
also,
a Tetris piece to me.
Also, it should be noted, they don't build it in just any building. They build it in the building on the right-hand side of your screen where it says ULA in big blue letters. Yep. That is the vertical integration facility, or vertical or vehicle? Vertical.
Let's call it the VIF.
The VIF, which is where they assemble Atlas V rockets and soon Vulcan rockets vertically on the mobile launch platform and roll it out. It looks pretty close to the pad from this angle because of the geometry. It is a mile-ish from the pad, from the actual location where the rocket lifts off from. It looks a lot closer in this camera view, but that's where they build it.
Good deal. All right, let's grab a couple more questions here. And again, y'all, you don't have to do a super chat to do a question. We also post public questions. It's just we can never get to all the questions because it takes you 10 seconds to type out a question, and then we talk about it for 5 minutes. Let's see here. How many Atlas launches are left after this launch? They have sort of a manifest, but they're not taking more missions, are they?
Correct. They sold the last Atlas last year. There are 24, 25 left if you count today's, give or take.
Okay.
There's some. We don't necessarily know all of the missions they sold, so it's a little hard to say exactly how many are left, if that makes sense. Because just like another provider, where all of a sudden 3 days ago was surprised, there's a launch on the 4th of February with a National Reconnaissance Office launch. Not all the launches get announced early, so roughly 24 to 25 depending. But that's the good ballpark for how many Atlases are left. And after that, that's it. I
They
mean,
better get
it
Vulcan going, huh?
it is the literal end of the line of the Atlas vehicle from the 50s at that point. Which
That's-
you can make the argument we've already crossed that bridge, but it's the last because the Atlas V was a huge, take nothing from the one before aside from portions of the Centaur, basically. But
right.
yeah, but I mean that would be it. That would be the end of the Atlas line.
Although Centaur is continuing with Vulcan, so there is still a little bit of lineage going there.
Little bit.
It's one of those something heritage, yada yada.
Yeah, exactly.
Building on things you've already figured out instead of starting from scratch. Let's see here. Somebody said, "How does this compare to the Astra slide?" And I think the little slider wins the drift competition. Like if you're looking at the rocket drift competition, little slider wins that one.
Little slider wins. Yes, we'll yes, that's a great way to put it. Yes.
Well, depending on your definition of win, yeah.
Well, hey, it kept flying. I'll give it to it. Like,
it did. Yeah, if it had fallen over and like burned down and sunk into the swamp, that'd be one thing. But that thing actually cleared the tree line for a little while. So good times. Of course, there we're referring to that Astra launch up from Kodiak, Alaska, that had an engine failure on liftoff, which left it with a like 1.01 thrust to weight, which meant that it sort of just hovered sideways off the pad and did not go up until it had burned off enough fuel to increase the thrust to weight, decrease the mass of the rocket, and then it actually maintained control and started to go up. We were live streaming that in partnership with Astra out there, and that was a memorable event. But when we say big slider here, hopefully this one, it's more of like an up with a little bit of sideward component to motion, not sidewards off the pad completely.
Now, what's very interesting here from our perspective, because of where they brought us today at on the Cape side, it will actually power slide directly toward the camera. So
really?
You will not see it go left or right from our camera, because it will actually come almost straight toward straight or away from us, but our angle is sort of dead on, so it will be coming toward us in its power slide. So we won't get to see that, but we will get to see that pretty epic pitch that it does as soon as it clears the towers and everything.
Yeah, that's why if you look at the current view, you actually can't see the solid rocket booster. It's on the exact opposite side of the rocket from this perspective, which is what's going to push it towards the camera.
So when this thing lifts off, I want one of you to say, "It's coming right at us." Anyways, really quickly, we were talking about towers, and we are really going to confuse viewers here because we have a shot at a pad that has not seen an operational launch here yet for Blue Origin. And this pad doesn't have 4 towers. I mean, you could argue about how many towers it has. It clearly has 1 lightning tower, a service tower with a lightning thing on top, a water tower, and a lighthouse. But that is actually looking from Steve's position down on Cocoa Beach across the way. What's the number on this pad?
36 is
36.
The blue pad, yes.
36 is the blue pad. So, of course, we've seen a lot of development happening out in that area, and hopefully one day we see operational launches for Blue Origin out of there. But, yeah, that's the Cape Lighthouse. That lighthouse is over on Cape Canaveral, the black and white stripy structure in the background. I'm surprised they didn't paint that like a rocket at some point, but maybe there's like a maritime law against that. Something about having to identify it as a lighthouse. But back to our Atlas 551 here today. It looks like we are coming up on 8 minutes before the launch. Again,
511. Just FYI, 511.
Did I say 551 again?
I have been saying it in my head
my gosh.
constantly, so I understand. I understand it.
I need
We're
like
so
a
used to
huge
saying that.
post-it
Yeah.
note. Just on the monitor, I'm just going to make a text pad with a 10,000 point font that just says 511.
Yeah.
Although you shouldn't get into the habit too much because this is actually the only 511 that will ever fly. Also.
Yeah.
So after today, you can completely forget about it.
That's my excuse right there. This has never flown before, and it will never fly again. So
yeah.
All right. So again, coming up on just 7 minutes and 30 seconds before the launch. There. What was our weather?
Well, so wait a minute. We're 7.5 minutes from liftoff. We should have polling here in 30 seconds.
Aha. Michael's going to tee that up for us here.
Yeah, and then I'll do the weather
engineers
after
and
that.
managers are polled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Ron McKee performs the final polling.
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulic.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
DC cube.
Go.
Operation support.
Go.
COM.
Go.
Umbilical.
Go.
ECS.
Go.
Red light monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle systems engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding.
And there you hear it. All systems
Yep.
are go for the launch on time, 2:00 p.m. Eastern Time.
Now, I appreciate that ULA does that. Like, the whole go, no-go poll is sort of a thing for launches, and not all companies broadcast that part of it, at least to that extent. And I appreciate the fact that ULA gives us that audio to listen to.
What's even better is some companies don't even do an audible poll like that. For some,
Yeah,
it is
exactly.
absolutely automated. They all do it, but like Roscosmos and SpaceX do not do audio polls like that.
Yeah, it's like, is the board green or not?
Right. And if it's
I don't know,
green-
just look at it.
Well, and to be fair, Arianespace doesn't do polls like that too. The board is just green, and it's very obvious when something isn't right. Yeah.
Yep. And I mean, I do like it. It really does sort of hammer home all the different people that it takes to make one of these launches happen. Remember, every single person that responded on that poll has an entire team of people behind them. They're just a representative for each one of those areas, and just the number of people that it takes to bring one of these launches together really is amazing. It's something that we don't think about a lot. We see the launch going, it's like, yeah, rocket, all right, that's cool. But just the number of people and the number of hours of work that it takes to make these missions happen, something to think about. Know that there are people behind these rockets willing these things into orbit.
And one thing we don't have to do a lot of willing today is to get the weather to cooperate, which I'm sure the meteorologist next to me laughed at. But I'm not going to look over because it was a dad joke, so I won't. But yeah, weather was predicted. Weather was a predicted 80% go today, and we ended. Oh, up to 90 prior to liftoff. So it was up to 90% chance of acceptable weather. None of the concerns that we had really materialized at all today. There is a light, very thin layer of cloud above us, so we will lose Atlas visually here. Not too far. We'll have it for a good portion of time, but all the major issues we were worried about for weather never came to fruition today.
Yeah. This is really one of the things you want to look at here coming up in 3.5 minutes. The Atlas with the SRBs sort of has a visual thing that you don't see. If you've seen a lot of the SpaceX launches, the rocket takes off and there's flames and stuff, but the Atlas actually, with the SRB, leaves sort of a pillar of smoke behind it. The ones I've seen I describe as it's sort of riding to space on a pillar of smoke. So be on the lookout for that. We should see a clear smoke trail behind the rocket from the SRB.
And those smoke trails are wonderful if you are trying to understand how does the rocket pitch, what's its pitch rate as it's going up. You can follow that contrail as it arcs out almost all the way back to the ground. Sometimes, which is really cool to see how they do it. Yeah.
And some days on clear days, we can even see wind shear, like upper level winds, where the winds are changing because the trail behind the rocket gets blown in different directions, and you can see some of the upper level winds sometimes.
That is so true. So true.
All right.
And I think we're under 3 minutes, right?
Yep, we are. 2.5 minutes about. So I think we're going to turn on y'all's camera, Michael, so that we could. Did I just say camera, Michael?
Did, yes.
Michael. I think you did. Michael will turn on the camera, Mike, so that we get that rumble from the SRBs and the engines on the rocket there as we come up to 2 minutes. Everything looking good. Everything green on the board from the go, no-go poll there. Weather looking good. Was recently upgraded to 90%. So hopefully in 2 minutes, Atlas V riding to space on a pillar of fire and smoke. with those two USSF inspection satellites aboard.
Yeah. And Dosh, just for your situational awareness with that microphone, because of where we are on Loop Road, probably not a good idea for us to field commentate the liftoff because we'll be close to that microphone.
Copy, so we get that echo from you. So we will handle it here from the studio, and y'all have a good time tracking that rocket. Good luck.
Wish me luck with the tracking, folks.
All right. So now, under 2 minutes, y'all. Again, this is the beginning of the window. Everything was looking good. But we are going to start to listen to the lapping water. Sometimes we get that lapping water off the microphone when we cut that one in. And see if Atlas V puts on a show for us and the Space Force today, I guess. They're not launching it for us, but we really appreciate to see them go. We're going to put a hold. I do see more super chats and stuff like that coming in. We appreciate the support. Same thing with questions. We'll get to some more of those after the launch. But at T-minus 60 seconds, let's go ahead and listen in as Atlas V hopefully comes to life for us. Now 30 seconds. And there's 10 seconds. We've got ignition and liftoff. Atlas 551 carrying the mission for the Space Force, sliding off the pad, going a little bit to the side there, has cleared the tower, and there is that pillar of fire that we talked about. Wait for that rumble. That sound energy is coming across the water at us right now. Pretty soon you won't be able to hear me talk anymore. There's that view from Cocoa Beach. Steve on the camera out there. People looking up the beach to see what's going on. And there, it looks like it's starting to get into those cloud layers that we talked about. No more visual there, but we've got a ULA camera, it looks like, that's still on it. A couple of ULA cameras. There's that one SRB. You can see the asymmetrical flames coming off the bottom. But even the ULA camera struggling with that cloud layer there. We may not reacquire it from any... Oh, there we go. On board for the SRB separation, it looks like. Thanks, ULA. It's just so odd with that one SRB sticking off the side. A lot of times we can see the Space Coast sort of in the rear view mirror here. It's not a mirror, I guess, but you get the point. And we should be coming up on Burnout and Separation for the SRB. Let's hope this live camera off the rocket itself sticks with us all the way through that. You can start to see it pitching downrange now. And there you go. The bump and tumble, the SRB successfully separating. You see how that front sort of bumps off first, and then the aerodynamic flow catches it and starts to flip it off the rocket. And now we are just on those main engines at the bottom of the Atlas V, the RD-180s. Curve of the Earth in the background and a lot of atmospheric spread on the engines. Look at how that exhaust just almost comes straight out the side of the engine bell. That's why rockets actually have engine bells like that, to help constrain the force in the direction they want to go without the atmosphere there to help push together that little pencil flame. Have you ever drawn a rocket and you got the little pencil of flame coming out of the bottom? Without the atmosphere, up here where the air is thinner, the exhaust is just going to spread out, and it's that engine bell that's helping direct that force backwards out to the rocket.
Yes, it is. Ain't it, DOS?
It is, and it looks like we can welcome our field team back. How was it, Chris?
Oh, I can still hear the rumble. It was really, really cool. I'm interested to see what our tracking camera got, because visually it was really cool when it hit the clouds, because it's sort of like very slowly disappeared, like a Star Trek transporter effect, almost.
It just like phased out.
Yeah, but the other thing, which is why I'm curious, it was a gray rocket against a gray sky for a long time. So
Yeah,
at SRB.
it was interesting, and eventually lost it in the clouds there. But it was still the audio was pretty good today, and I think sometimes the cloud layer helps with that.
Yep. And yeah, that's the thing. Like, seems like a great vacation, being on a beach while getting to watch a Atlas V launch. There,
Right.
looks like we've just got the animation of the fairing separation.
Oh, and that little load spreader and load
Yeah.
distributor too.
It looks like they're launching a magnet.
It does,
The
doesn't
two
it?
satellites next to each other. This looks like some sort of supervillain space weapon, like a magnet laser. That doesn't make any sense, but whatever.
Yeah. Now, one of the interesting things to talk about with the Atlas V that's very interesting is the first stage is immensely powerful. So it will actually do more than about half of the velocity change needed to the spacecraft to get into orbit, and then it will hand off to the Centaur upper stage, which is unusual because usually the first stage burn ends and the second stage is like, oh my gosh, I've got 75% of this left to do. Because that's how normal rockets work with stages that have very high thrust to weight ratios for the second stage. But and we just had a Atlas stage separation there, which was very good. So the Centaur engine is igniting now. So exactly what we were just talking about. So if you look at that velocity in the corner, right, 4.8 kilometers per second, but orbital velocity is 7.7. Falcon 9s typically drop off. Their second stage is around 1.7 kilometers per second. So huge difference, because while the Centaur upper stage is extremely efficient, it has a very low thrust to weight ratio. In fact, the thrust to weight ratio when you ignite the Centaur upper stage is usually about 0.8, not 0.8. So it's not thrusting at a rate that's greater than the mass of the vehicle when you ignite it. So you're going to drop in altitude. So the first stage will give you a whole bunch of velocity and throw you up really, really high so you don't come back down into the atmosphere before the high efficiency Centaur upper stage can finish your burn to your initial parking orbit.
And that's what we're looking at on the screen.
Nobody
here,
asked,
right?
but there you go.
Yeah, nobody asked. That's what we're looking at on the screen here on the right-hand side. Those are the two satellites. That's the payload on the special adapter that Thomas was talking about a little bit earlier. And that is the Centaur upper stage. Well, that's not the Centaur upper stage, but that's the guy at United Launch Alliance.
There's a good beach view. Nice.
Yep. And you saw most of those people start to look off in that direction, especially when the rumble started to get there. But just imagine, I've actually taken my family down to Florida for a vacation, and it's very hard. It's very hard to like plan something to go watch a rocket launch, right? Because you're traveling in from out of town. Is it going to scrub? Is it going to be delayed? Where do you watch it from? We went up to Playa Linda to watch an Atlas fly, and the first day it actually scrubbed. Oh no! We were stuck at the beach. What were we going to do? It was the way I sold it to my family, like, let's go to the beach. There's going to be a rocket launching in the background, but even if it scrubs, you go out there and you're still on the beach at the end of the day. Chris and Thomas, how are y'all on time? What is
right now, we've got a little bit of time. I believe that Centaur upper stage is also still going. Of course, DOS, we've got your favorite camera view there for you, our empty launch pad at the end of the day. But we can maybe take a couple questions.
All right, let's see if we can't.
Yeah, no one's being told to wrap up yet. Yeah.
Okay, just let me know as soon as y'all are needing to wrap up. Let's see. See if we can grab a couple. Where is United Launch Alliance's control center? Where do they fly these rockets from? That's a great question from Terry Heaton.
That is a good question, and there are kind of two answers. There is a launch control center and a mission control center, which is how most launch providers do it. You have a somewhat local location for launch controllers, and then you have a kind of a higher picture, bigger picture mission control center somewhere else. The launch control center is here at the Atlas Spaceflight Operations Center, or the ASOC, which is actually right behind us. There's a building with some windows poking out over trees so they can see the pad, although most of the controllers are looking at the computer screens at the time of launch. That's the same building where they actually house Atlas V boosters and Centaur stages prior to launch processing and things like that. But there is a launch control center in that building, and so that is where the go, no-go poll that you heard primarily is in there, I believe, as well as all of the engineers and their support teams for that launch. But they are also supported by engineering teams at ULA's headquarters, which is in Centennial, Colorado, not too far outside Denver. And that's kind of the bigger picture mission control center. And that's where a lot of the ULA's engineering happens. And there's lots of engineering teams who are also on console for every launch at that location. So 2 different control centers where launch teams are today.
Gotcha. I'm going to speed run a couple more questions here to try and get just a few more in. There was another great question, space debris. How does ULA deorbit the Centaur, or does it become debris? Does it go to a parking orbit? What's going on with this mission today?
So ULA does one of 2 things with the Centaurs. So sometimes they add single solid rocket boosters like we saw today in order to allow the Centaur to maintain enough propellant in its tanks to do a deorbit burn. However, this particular mission needed the single solid to get to do a direct insertion to geosynchronous orbit. So the Centaur is going to do its burn to get into orbit, then do another burn to throw the apogee out to geosynchronous transfer, coast up to there for about 6.5 hours, reignite its engine to circularize the orbit. Once you do that, even with a single solid rocket for the mass of the payload today, there isn't enough propellant left to deorbit the Centaur. So what they do is they move it into a slightly higher orbit than geosynchronous, and they allow all of the propellant to basically passively escape through the engine and the systems so that you've completely vented it down, you've removed the propellants that you can, you've removed the pressure so there's no risk of an on-orbit explosion of the Centaur. And then it just sort of sits there in geosynchronous orbit for eternity until the sun decides to give it up. Yep.
Gotcha. Let's see here. I think I can grab maybe one more question. So we've heard some things about and since ULA is showing manufacturing processes here, we've heard some things about where things are being manufactured. Was this fairing manufactured in Switzerland? Was it manufactured in Decatur? Are they moving those manufacturing facilities around? What's going on with that?
So I believe this was actually the last fairing. We've talked about this a little bit in prior launch broadcasts. This was the last autoclave manufactured fairing. All of the ULA Atlas V fairings and future Vulcan fairings are made by a subcontractor called Arianespace, same contractor that builds the payload fairing for the Ariane 5 rocket. And that, I believe this launch was actually the very last Atlas V mission that is using a fairing built in Switzerland across the ocean in the normal autoclave fashion, which is basically a way of saying a really big oven that is used in the manufacturing process. The new method that has been used on a couple Atlas V missions already and will be used for all of the Vulcan fairings and all the Atlas V fairings from now on are being made here in the United States in Decatur, Alabama, actually right next to where the Centaur and Atlas V stages are built at the ULA rocket factory. Still by Relativity, but they have completed a production facility there for the new manufacturing style for those fairings, and all of them from now on will use that facility. But this mission was the last one to use the ones built in Switzerland.
Good deal. Another good question there. Again, y'all just trying to get a couple of the last questions in. Let me do this as well. A lot of super chats came in. We always put a moratorium on super chats when it's launch time so that we're like, thanks for the support. In the background, the rocket's taking off. Hermanar, thank you so much, says, love all you folks. Steve DeCo says, keep up the great work. We appreciate you. Good job, NASASpaceflight. Actually, nice job, says Gotam. We've got Wolfram, says, been following you guys since the Cargo Dragon Demo 1. Keep up the awesome coverage. Y'all keep showing up, Wolfram, and we will keep sending y'all, I guess, photons to look at of rockets taking off. Jim Cavett says, thanks, y'all, for another great stream. We've got Cynic in Chief says, let's go Atlas, and inquiring about ad rates. Thank you so much for Cynic in Chief as well. We've got the Thomas Fan Club checking in from Moldy Space Industries. Appreciate you there, Moldy.
Thank you.
Conservative Space Nerd, thank you as well. BTNHOH, thanks for the support. And we've got, let's see here, Delta 23 with a bit of a question, Delta 23, I think your question here about being accredited for press at media events is probably best sent via Twitter. Maybe find at NASASpaceflight or Chris Gebhardt. He's at ChrisG_NSF with that specific question on Twitter or Discord if you're in the Discord or something like that. That's probably the right place to ask that question. And then James Jury's got you as well. Thank you for the support. There's another asymmetric rocket. Nice. And lastly here, David Dean. I think I've cleared out the entire super chat, but a question from David Dean. How soon could we expect to see the first Astra launch from the Cape? And this is interesting because just recently... Oh, thank you. Main engine cutoff. So the Centaur has cut off the main engine there. Thanks for jumping in there, Michael. Which is a good sign. Still waiting for payload separation there. Do we have timing on the payload separation?
Sorry, can you repeat that really quick?
Do we know how long it will be before payload separation?
A very long time. So remember this. So the Centaur just shut down into a low Earth orbit parking orbit, and after a brief coast phase, they're going to relight the engine to send the trajectory all the way out to the geosynchronous altitude, and then it's going to be like 6 or 6.5 hours of another coast phase prior to that circularization burn and payload deploy. So we got hours. We're not going to stay live for all of that. Most of those final updates are going to come via social media, via ULA.
Good deal. All right. Thank you, Thomas, for the update there. So the question there, that last question, how soon could we see the first Astra launch from the Cape? Y'all know we've been working pretty closely with Astra to bring y'all coverage, and there will be an Astra launch from the Cape. Actually, that is the Astra pad in the background there. Coming up soon, TM. How's that?
Soon, TM, exactly.
Soon, TM, right, Thomas?
Stay tuned for coverage of that, but yeah, stay tuned. And on that note, Das, I believe we're actually going to start wrapping it up here as well.
All right, good deal. So, folks, I believe that will bring us here to the end of our coverage. United Launch Alliance on that Atlas 511. I actually wrote a note on the desk to make sure I said 511 that time. The USSF-8 mission carrying those 2 inspection satellites up. It's not 100% complete yet, but the rocket is on its way. It's made it into that parking orbit. Still a little bit to go before it is mission success. Be looking on Twitter for Tori Bruno to do his counting, his best Count Von Count impression, where he types out the number of successful launches. That is usually something that does not, well, that's always something that doesn't come until success of the mission. But for now, let's run through the people involved with today's broadcast really quickly. Starting with Chris Gebhardt out in the field. Chris, if you're packing up, we appreciate you being out there today. Thank you so much. I think he popped for a second, but that's okay. Chris was out there in the field. Hey, also, Thomas Burghardt was out in the field as well. Let's not call on them to say anything because I know they are packing
Here,
up.
I can say a brief goodbye. Thank you, everybody, for watching from Cape Canaveral. We'll see you next time.
All right, that's Thomas Burghardt out in the field doing the tracking on the launch today. Also, Julia Bergeron stepped through. Julia, thank you for joining us.
Thank you for having me.
Excellent. We got that view from the beach down at Coco from Stephen Marr. Stephen's not on comms, but be looking on Twitter. He knows he's got some remotes set on the pad, so after they go get those remotes, you can follow him at SpaceCoast_Stu. There's a missing E in his name, STVE, to get those remote shots after they can recover them. Back in the studio, Michael Baylor was, well, that's my name there. Michael Baylor was clicking things and making the lights blink correctly, which is cool. And then also, my name's John Galloway for NASA Spaceflight. You may know me as DOS, whether you're watching over on my Twitch channel or you're watching on the NASA Spaceflight channel. We appreciate y'all joining us today. We hope you like the coverage. If you haven't yet, make sure you click the like, subscribe, turn on the notifications. This is what we do. Live commentary on launches, our own cameras, not just recycling the feeds, trying to do some Q&A, answering some questions, and hopefully doing things in a way that makes it interesting and entertaining and informative for y'all. But for now, that's going to be the NASA Spaceflight crew signing off, and we will see you nerds later.
We have liftoff. Propulsion continues to be normal.
The chamber pressure looks good.
Following up.
Roger, roger, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight Alpha, SE off. Say again, SE off.
Yikes. You bet. Concur. We don't need any more of these.